Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome to this course, Introduction to the Kotlin Programming Language. This is a presentation of Coding Bootcamps. My name is Jim Sullivan. I am your instructor. This is session 1, so we'll present the Kotlin overview, installation, and setup. Our prerequisite is a basic knowledge of programming and a basic knowledge of Java. We'll actually see examples of how Kotlin is closely related and interoperable with Java. Our Kotlin overview and installation, we'll talk about why Kotlin, what are the advantages, and the install and setup from the Kotlin command line, and install and set up Kotlin through an IDE or integrated development environment. A little bit about the 10 highlights of Kotlin. First off, Kotlin is statically typed. So Kotlin is very concise. It provides a rich set of idioms or shortcuts to perform common tasks. So when we create Java objects, plain old Java objects, quite often we have to create a class. It's a lot of syntax. We have to encapsulate the data. We have to add methods for setting properties. We have to add methods for getting properties. We have to add methods for converting to strings. Kotlin has the reputation for just being shorter, the same type of application with less syntax. And Kotlin provides this very concise syntax, which allows us to be able to value our properties and to convert to strings and to return our strings. So much less syntax with Kotlin. And Kotlin is safe and secure. So every variable in Kotlin is non-null by default. So we can see here, we declare this string, we can see the str is of type string. We see the string here, hello world. It is non-null, so it can't hold a non-null value. If we set str equal to null, we'll get a compile error. However, though, to allow a variable to hold a null value, we must explicitly declare it as nullable. So we can see it here. So this can be null. Since Kotlin knows which variables are nullable and which are not, it can detect and just disallow unsafe calls at compiler time that would otherwise result in a null pointer exception, which actually can save developers a lot of headaches. And we can see here, here's again a nullable string length. So if this would return a compile error, because if it's a null string, it's not going to have any length. And Kotlin is also explicit. So Kotlin does not allow implicit type conversions like Java does. So I'm sure many of us are aware of classes and objects in Java where you are passing in the math class, or the math object is a good example. Quite often you will pass an integer, and your integer will get converted to a long or a double right in the math function. So in that way, you have you don't have to worry about doing type conversions with Java. However, with Kotlin, if you want to do a type conversion, you have to call methods like toLong or toDouble, so you have to explicitly run the type conversions. And also, classes in Kotlin are all final by default. You need to mark a class as open to allow other classes to inherit from it. Similar, all the properties and member functions are also final. So you need to mark a function, or the equivalent is a method in Java, a property, as open to allow child classes to override it. So a subclass can inherit and override a method, but you have to explicitly mark it as open. Kotlin is considered to be easy to learn, particularly if you know Java. You can easily pick it up. It is functional as far as writing methods, and it supports object-oriented capabilities, completely interoperable with Java. There is excellent tooling for it, so lots of development environments, including IntelliJ, Eclipse, and many others. You can build applications for the server side, for Android, a browser, and a desktop, and Kotlin is free and open source. You can set up and run Kotlin programs in several ways. You can either install Kotlin's compiler and run Kotlin programs directly from the command line, console level applications, or you can install and set up Kotlin through an IDE like IntelliJ or Eclipse. Currently, IntelliJ probably has the biggest market share for Kotlin. However, Eclipse is a great alternative, and there are also many others that have rich sets of tools for Kotlin. So to set up and install Kotlin from the command line or from your integrated development environment, please go back to your course materials and read the course materials and follow the step-by-step instructions to install and set up Kotlin, either through the command line or the IDE, integrated development environment. We are going to do all of our examples out of IntelliJ. And again, IntelliJ gives you a great environment for Kotlin development. So let's take a look at an example. This is IntelliJ, and we have created a Kotlin project, and it's very similar to a Java project. We have the concept of a package, so you can see the package here in our application, our Kotlin application. Methods are called functions in Kotlin, and you can see here how it's similar. We have the main method, and we are passing a string of arguments. And here we also have the print line. So here we are going to, you can see the package right here and see the Kotlin file. This again is IntelliJ, and we are just going to go ahead and click on run, and we're going to run this application. And it runs a build, and here's the output down here. And as you can see, it actually called a Java development kit. So how interesting is that? Over the next few sessions, we're going to switch to hands-on training instead of lectures. So we will be going over our labs. One thing about programming, you really can't sit through a lot of slides and learn it. You've got to do it. So we will be going into our IntelliJ and actually writing some basic applications. And your course materials cover in detail all of the topics that are discussed in the course and the remaining sections. And you'll also have the source code for all of the applications that are demonstrated and all of the examples that we go over. So our next session will be writing our first Kotlin program. So stay tuned for that. Before we get there, your learning materials have information for private coaching sessions. So private tutoring sessions for software design and engineering. There are weekly and monthly plans, and there's also private tutoring available for the Kotlin programming language. Some follow-up courses. Learn blockchain development with Quarta R3. So Kotlin is used a lot with Quarta for writing Quarta contracts, and also Java programming at the basic level or the intermediate level. So thanks again for watching this session, and stay tuned for the next session. Welcome back to this course, Introduction to the Kotlin Programming Language, a presentation of Coding Boot Camps. This is session 2, our first Kotlin program. So we're ready to begin to write our first Kotlin application. So here we have our development environment, IntelliJ. So what we'll do is we'll go up here to the File menu, click here, say New Project, and we're going to make it a Kotlin project, and we can go ahead with this JVM, that's fine. Click Next here. And we have to give it a name and a location. So here we will actually call this, we'll create a new folder for it. Kotlin Session 1 Proj, short for project. Navigate in. And we'll just call this one, we'll put a 1 after that because it's our first one, and click Finish. And we'll say in this window. Okay, so here we are. So let's expand this, and notice here you can see the source folder. So the source folder is here, very, very similar to a Java project. First thing we're going to do is create a package. So Kotlin has the concept of the package, so we'll right click on our source folder, say New, and navigate to Package, and I'll just put our package name is going to be hello_world, and we'll click OK. And here we have our package, and now we want to create a new Kotlin file. So we'll right click on our package, and we'll say New, and we'll say Kotlin file or class, and we've got to give it a name. We'll name the file hello.kt. It's a very friendly application. Click OK. And you can see that now our class or our file opens up here in the editor. And what we'll do is we will paste our code into the editor. I've already written it, and I'm sure you don't want to watch me write it. So here you can see our function and our main function, and what we're going to do is print the line hello world. You can see the curly braces here and the package reference. So we'll go to File, Save, and let's run this. So we'll go up here to Run, or we can click this Run button here, or we can right click here and run the file. So let's go ahead and run. And it's going to build. You can see the build running down here. Might take a, here we go. So we can see here the output right here. And you can also run using this run button. If we want to clear the console, we can click on this icon here that looks like a bin, a trash bin. You can click that, and we can also run again, and it will run the application again. So please take a look at your source code, and please go ahead and key in this application, and just to get the practice of actually working with the syntax. Thanks again for watching this session. Our next session, we will take a look at some types in Kotlin. Welcome back to this course, Introduction to the Kotlin Programming Language, a presentation of Coding Boot Camps. This is session 3. In session 3, we are going to do a group of brief videos on Kotlin variables and types. Here, we are going to start off with a Kotlin project that we are calling.
Thanks for watching. Feel free to add your questions as comments down below.
3A variables. And within this project, we have our package variables, and we have our Kotlin file or class called variables. And we're going to focus on variables and declarations. So there are different ways to declare variables in Kotlin. We can declare them as immutable or mutable, and we can also create inferred variable types or explicit variable types. So here's an example right here of our immutable variable. So we have this variable right here, and Kotlin is able to infer that this variable is a string. Notice there is no string declaration here. But it's also declared using val, so that means it is immutable. So we could not change it. If we went down here and tried to update the name or the value of name, we would see here that it results in an error. And here we can also see that another variable here, another string, is declared explicitly as a string, and is also immutable. Here we can see mutable variables. So we have our var, which we use var to declare mutable variables, and this variable country is inferred as USA, and then we update the value here. So we give it a new value. And here you can just see we put out the output here to the console. And just like we discussed, there is type inference. So we can see here again, there is an inference of string here. We're using val, which makes this variable greetings immutable. There's also an inference here as int, even though that we're saying it's a year. Be careful, because Kotlin will infer this type of declaration or initialization as an int. And again, it is immutable. And then we can see explicit declaration here. And if we look a little further, we can see that we are not initializing the mutable variable language. We're not initializing it at declaration time. So we have to use the explicit declaration. So we have to declare it as a string, and then later on we can value language. So let's go ahead and run this. So what I'm going to do here is just go to run, and we're going to run variables kt. Let it compile. And we can see here we have output Satoshi Nakamoto. We have output the updated value of country. We have output other name Rick Bass. And we have output the hello world. The int 2018. We have output hello 20 and our language French. In our next video, we're going to look at arrays. Here we are in a new Kotlin project that we're calling 3B for basic types. And we're first going to look at arrays. So we have our basic type package, and the first Kotlin file or Kotlin class is called arrays. So we have our main function here. For those of you that are not familiar with arrays, they are a single declaration with multiple values. So we can declare, say, numbers here, but give it multiple values. And these values are actually kept. The Kotlin compiler actually keeps track of the sections of memory where the values are kept. And the values are kept in specific positions. So that's also important. The value and the position in the array are important. Here's, we are declaring our arrays. So we have our var here, so we can see that is mutable. And we can see here how the arrays are initialized. So this number is of type int, and it has these 5 values. Now, it's important to know that arrays are 0 indexed. So the first member is the 0th member. Second member is the first. The third member is the second, and so on. So we can see here the values, and some are of mixed type. We can see here, so that's one thing Kotlin gives us that's really useful. We declare it as type any, and the way that we pass in Kotlin makes these inferences of the type of data. So that's important to know too. And then we can also enforce types as well. So even though we're declaring this as integer, you can see here array of, and we're using this int here as enforcement, and then we pass in the values. So again, array indexing is very important. So in this array of double variables, we can see here that the 0th member is actually 4. And then a little bit later on, something for you to try, you can remove these comments and actually print out how that we can return the members of the array at different positions. So you can see here first element, second element, and so on. So we can remove these comments, and then we can try other ways to access the members. Here we have some primitive arrays, and these correspond to Java data types. So we can see here characters, and notice the single quotes. And then we also have our int arrays here that correspond to the Java ints. For creating arrays, so this is how we will create an array. In this case, we're doing a calculation. So we're declaring the array type, the size, and then we're doing a calculation. And what this will do is iterate through the members because it knows the size. And we can see here that we are actually outputting, just getting some data from some of these arrays. So here is one way to access the members of an array, is to use a for loop and to iterate through each position in the array. Let's take a look here. If we run it, what we'll do in this case, because we have multiple classes, we will select the class that we want to run so we don't get confused. We'll right click, and from the context menu we will select run, in this case arrays KT. Let it compile, and then we'll see our output here. So we are outputting the members of our string, of our int array, of my int array. We can see them here. Then we are outputting the members of animal. So we can see dog, cat, dog, lion, tiger. And then a little bit later on, we're also going to try, you'll remove these comments, and it will go to my square array, where we were actually building the array, and we'll run this as an exercise to output its members. Welcome to this video on numeric types. So we're in the same project, basic types, under the same package. With the numeric types, Kotlin gives us different data types to manage our numeric data. We can start off here with the byte and the short. So this would be a short integer, so it does not use that much memory if we know it's going to be a short integer type. And then we also have int, which is which uses much more memory. So, but we can see here that we get the inference here that my int is an int. Notice these are declared as bytes and shorts. Right here, there is an inference to integer, but the suffix, the L here, that's not part of the value. That is actually a suffix here. It's letting Kotlin know that the inferred integer is a long integer, a long value, and that requires more memory. Was also here another inference of a float, but the F is again not part of the value. It is a suffix, so Kotlin is able to distinguish this value as a float, or this data type as a float. Otherwise it may be a double. So notice these are very similar except for the suffix F, which allows Kotlin then to type this value or this data as float. We can also use underscores to make numeric values more readable. So as number values get very long, we don't use commas in computer programming, but we can use these underscores. These underscores don't change any values, but they make it more readable. So we could almost say the underscores are substitutes for the commas. And we can also use hexadecimal and binary. If we use binary, which is really shorthand for the ones and zeros that ultimately all computers process. But if we look here at hexadecimal, if we prefix with 0x or 0 uppercase x or lowercase x, we can pass in a hexadecimal value for our numbers. And if we prefix with either a 0b, either uppercase or lowercase, we can pass in the ones and zeros for a binary. So just take a look at this and see the numeric type examples. And as you can see here, we are outputting each of these so we can see the output. Again, what we'll do is go back over here to our Project Explorer. We'll right-click on the Kotlin class numeric types. We'll go down to run numeric types.kt, let it compile, and we can see here that we are seeing the output right here of all of our numeric types. Welcome back. We are still in the Basic Types Kotlin project. We have our Basic Types package, and then we have a new Kotlin class or file called strings.kt. The basic type we're going to look at are strings. And strings are in Kotlin are very closely related to strings in Java. They behave almost identically. So we can see here a declaration, and again, this can be an inferred declaration. This is mutable, so Kotlin is inferring this mystr to be a string. Down here, we can also take a look here at string indexing. So strings are classes, just like they are in Java. They're also arrays. They're special types of arrays. And since they're classes, we have methods. And since they are arrays, the position's also important. So we have a right here a mutable string, an inferred string called name, and we can return the first character by just passing in the 0th member and returning that the first character in name, and it'll return J. Last character we can call, because this is a class, we can call the length method and subtract 1, and then we'll get the last character in John. We can also use escape characters. Right here, notice we're using the /n. That's not printable, but this will actually print as a new line. So that's why they call it an escape character. And then if we come down here, this is a mutable string. So we'll have my escape string again, but this time we'll do /t, which is tab, and you can see the difference, so we can do that for an exercise. There's also a multi-line raw string, which we will pass like this with the double quotes and then the text in between. Let's run this Kotlin class. So we'll come over here again to the class, right-click on the file, the class file, go down to run strings.kt, and we'll observe the output. So we have here the John, and we have the J, which is the first character, the N, which is the last. Then we have our hello reader, and we have our new line right here, and then we have our multi-line string here. So it is able to, in this case, the way we're passing the quotes, it's able to see or infer the new line. Next, we are going to look at type conversions. In our first session, we talked about how Kotlin does not allow implicit type conversions. It must be an explicit type conversion. So let's take a look at a few examples here. We originally value myInt as 100, and here we are passing the toLong method, and that does the type conversion from an integer to a long integer or a long. We can see here double value. We make this declaration, and we want to convert it to an integer. So here we must pass the toInt method. And notice here it just simply truncates it. So similar to Java, it truncates everything to the right of the decimal point. So you can lose value with this type conversion, so be careful. Here is how we convert an int here, 1000 int value, to a string. We pass the toString method. And here we have a string that we need to convert to an integer, so we pass the toInt method. So, but be careful, it's got to be numeric in order to convert properly to an integer. It's got to be something that's convertible. So
if you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
It's same rules as Java. It is possible to have an error here. If we just had ABC here and tried to call the toInt, that obviously would return an error. So here we see some output of our original data and the converted data. What you want to do is continue this pattern and output these final two, the conversion from our another int to string and from our string back to an int. Let's run this now. So what we'll do is go over here to type conversion, our Kotlin class. We will right click and go to run, and we'll see here our type conversion here, and we can see the data loss right here for our conversion from double to int. So please look out for that. Thank you so much for watching these videos on Kotlin arrays and types, and stay tuned for our next videos. Welcome back to this course, Introduction to the Kotlin Programming Language, a presentation of Coding Boot Camps. This is session 4, Kotlin Operators. Welcome to this video on operations on numeric types. So let's take a look at some of our operators. We have a Kotlin project here we call project for operators, and we have our package that is also called operators. And let's take a look at some numeric operators. So we can see here the assignment, which we looked at earlier, but here we can see the parentheses. We are doing addition here between these two integers, and then we're also doing some addition and dividing it. So we're doing some division right here, and then we're doing some multiplication. And the compiler is able to work out the order of operations here. The ultimate result will be 450, and it is a very typical order of operations. Same as Java, same as C and C++, same as .NET. We can also see the subtraction operation here. What we're going to do for exercise is remove the comments and also remove the comments here, just get the subtraction working. And we're also outputting the value of C here. There was also some shorthand operations. So the plus is increases or increments the value by 1, so we could take A, and every time this line is executed, A increments by 1. So first time it would go from 10 to 11, 11 to 12, and so on. And then the plus equals is adds to itself. So we can see here if we do plus equals 5, we take 20, and we do plus equals 5, it'll become 25, and then we output those values. So if we run our exercise here, we're just going to select the Kotlin class file, right click, we'll click on run, it'll compile, and then we'll see here the 450. We'll see here how 10 went to 11 and 20 went to 25. So that's it for this video. Again, please go in, follow the instructions, remove some comments, and get the subtraction working. Stay tuned for our next video where we take a look at some bitwise operators. Welcome back, and we're still in our project for operators. This is our Kotlin project called For Operators. We see our package called Operators. Right now we're going to look at bitwise operators, and in Kotlin, bitwise operators work the same as they do for Java, C, or C++. They work right at the binary level or the bit level. The two most popular ones, or best known, I guess you could say, are shift left, which is SHL, shift right, which is SHR, and this shifts the position on the binary number line. So if we have a 1, that's actually in binary 2 to the 0th power. And if we shift left, if we move to the left 2 places, so that's what we're doing. We're taking the value 1 and we're moving it from 2 to the 0th to 2 to the 2nd. 2 to the 2nd is 4. So we shifted left. Similar here with shift right, SHR. We start at 2 to the 4th, which is 16, and we shifted 2 places back. So we go from 2 to the 4th down, from 2 to the 3rd, 2 to the 2nd, and 2 to the 2nd is also 4. The AND here returns a 0 if the operators are not identical, and it returns a 1 if they are. Take a look at the other operators. They are exactly similar to C and C++. Again, these are bitwise that operate right at the binary number line. Welcome back, and in this video we are still looking at operators. We are still in the same Kotlin project for operators, and we are underneath the operators package. Here we're going to look at operators as related to booleans. So we are going to look to see how the operators evaluate 2 values, 2 or more values. So let's take a look here. We can see A and B, and we have the values again for A and B here at the top. A is 10, B is 20, and it's evaluating this expression right here. So A is less than B. So in other words, it's saying 10 is less than 20. That happens to be true. So this Boolean value here would be set to true. So Booleans can only have the value of true or false. Likewise, we could see here that if we change things around a little bit, we can we have this Boolean right here. It's currently commented out, but we're saying A is greater than or equal to B. So we see that expression there. We would see that expression would be false. And for our exercise, what we're going to do is remove these comments here and take a look at what happens when we actually evaluate this expression and see how is A less than B Boolean is updated. So please complete that exercise. And one other thing, we're just going to look at operators can be converted to method calls. So you can see here that instead of saying print x plus y, we can actually use a method call. We can call plus on x and pass in a y, and that will give us the exact same result. So you can see here it's equivalent. So also please take a look at that. You can see that we are using the print line here, so you can see the output for that. Let's go ahead and run. So again, we'll right click here on our class file and we'll click run. And so what we're looking for here is our bitwise operation here, and you can go in here, feel free to go in and put in other or output other bitwise operations. You can see here our 9 is output here. We have the equivalent to x plus y, or calling the plus method here and passing in y. We get the similar results. And for our Boolean value here, we can see that currently A is less than B, so we get true. But if we make a change here, let's see what the output there would be, and we may want to format this a little clearer so this output is much more readable. So please complete all of those exercises and stay tuned for our video on strings. Hi and welcome back. We are still in the same Kotlin project. We're in 4 operators, and we're going to take a look at operators on strings. We saw a little bit earlier, we can call methods on strings and return the first character in a string, the last character, or any character on a string. And here we're going to call operations on strings related to what we call concatenation. And concatenation is a fancy word for actually combining or It's a way of formatting, so we can combine strings, we can insert spaces, just so we can format to make our output more readable and have it make sense to our users. If we take a look here, here again is our Kotlin, Kotlin class file, and we have our main function. We have our mutable strings, and obviously these are not explicitly declared. We talked about that. We have one down here that is explicitly declared though. So we have Raj Johnson, and what we're doing here is we're using the plus sign. So the plus sign is our operator. It's our concatenation operator in this case. It's an example of what we call an overloaded operator. So it actually looks at what Kotlin's able to look at what the overloaded operator is doing, and it's able to call the correct method. So in this case, we see that there are strings to the left and to the right. So it becomes the concatenation operation. It's not adding integers. So if we take a look here, it takes first name, which we know is Raj. So it's initialized as Raj. And then notice we're concatenating a space, and that would be for readability. Then we're concatenating last name, which is Johnson, all lowercase. So we can see the output here. Then when we go to the print line, we're actually able to do this full string concatenation that print line gives us here with the $sign. It's able to do that concatenation and that temporary conversion to strings for output. So if we take a look here, if we go ahead and run this, run our strings, we can see that this is good, and we see Raj Johnson right there. Then there is string interpolation, and string interpolation actually helps us perform some functionality or some operations within a string. So you can see here we are declaring two integers, a and b, and we are obviously doing this implicitly, and then we have our print line output where we are inside of this string. We don't need to concatenate because the print line is giving this to us by interpolation. So we can see here we use the $sign for our variables, and then we can pass those in, and then we can see here we can also use string interpolation here on this operation and convert that to a value. So if we look down here, we can see the average of, and we see 12 and 18, and we're running the interpolation here. So the $sign looks like an S, so it means really present the variable as a string. That's really what is going on there, and we can see the output here. So please take a look at this, run it a few times, and make some updates on your own. So thank you for watching these videos on numeric operators, on bitwise operators, on boolean operators, and also on string operators. Stay tuned for more videos. Welcome back to this course, the introduction to the Kotlin programming language, a production of Coding Bootcamps. This is session 4, Kotlin control flows, if blocks and loops. In this video, we are going to look at the Kotlin if statement. So we can see here we have our Kotlin project, which is called 5a conditionals. We have a package here called conditionals, and we have our Kotlin class file here. In the main method of this Kotlin class file, you can see here we have an integer declared, a mutable integer n, which is 34. And with the if statement, we are going to test the statement, and if the statement is true, the if block executes. If the statement is false, the if block is skipped by the application or by the execution. So we can see here our if block is really defined by our curly braces. So we have our if, we have our statement, we have our curly braces. In this case here, we're using modulo 2, so we're dividing 34 by 2, and if there is a remainder, that's the modulo. The remainder is equal to 0, the number is even. So we're actually using the if statement in two forms here. This is a very traditional if block, and this Kotlin in this case is identical to Java or .NET or C++. We can see here the curly braces. If there's a single line in the body of the
Thanks for watching. Please like and share this video.
if statement, the curly braces are optional. So we can see here that these two lines here, or these two if statements, are equivalent. If we take a look here, there's an if statement at testing if n is equal to 40. So we can see again the Boolean statements here are identical to Java, C++, .NET. And this one, in this case, is going to be false, so the execution will skip this if block and continue after the curly braces. And then we're also going to test this statement for true or false. In this case, it looks like it's going to be true, so therefore this if block will be executed. So again, if you are very familiar with C, C++, Java, the if statements are identical in Kotlin, the way that they are used and the structure. Let's execute. So we'll go over here, back to our project. Because we have multiple class files, the easiest way to make sure that we're executing the right one is to just select it, right-click, and from the context menu, run our ifelse.kt class file. It will compile. And we'll see here, we'll see that we're getting the 34 is even from this if statement, and then from the if statement here that doesn't have the curly braces, because they are just two different ways of writing the same thing. We have a single line in the if block. Notice here we don't get any anything about being equal to 40, because this statement is false, so it's never executed. But n is greater than 30, so we get this statement, n is greater than 30. So thanks for watching this video, and stay tuned for the next video. Hello, and welcome to this video on the if-else statement. So the if-else statement is, again, identical to Java, .NET, C, C++, and so many other programming languages. We have an if block, and then we have an else that's executed in the event that the if statement is false. So if we take a look at it, we have essentially two code blocks in an if-else, and only one is executed, though. So the expression here in the if statement is evaluated. If the expression is true, the if block is executed, and then the if block is exited. So the else block never executes. However, if this statement in the if is false, the if block is skipped and the else statement is executed. So and that is identical to Java, C++, and just like we just talked about. So let's take a quick look at an example. So here we have two variables, A and B. A is 35, B is 55. And we're going to test if A is greater than B, and then see which block executes. So we'll go over here again to our project, and we'll select the else if, again, the else if Kotlin class file, right click, and we'll go down to run the class file. It'll compile and build, and then we'll see, A is not greater than B, so therefore the else, we can see here in the else, that block executed. But if we make a change, so let's clear this, click on the little bin symbol and close the console. Let's say A is 65. So now A will be greater. Then we'll save. And again, we will right click on the class file, click run. And we can see here that 65 turned out to be the max. So we're calling this the max function, which compares two elements that are passed into the max function and returns the larger number. So that's it for our if-else video. Please stay tuned for an if-else if video. Welcome to this video of using an if statement as an expression. So if we take a look here, we can see that we are actually using our if statement to value a variable. So we have an integer variable here that we're calling max, and we're using an if statement based on some initialization or some update or some variable value. We are then using our if statement to determine what a variable would be, and then we're outputting that information here just so we could see it. So in this case here, we are evaluating this statement. If A is greater than B, we will return the expression right after the if statement. So max would be valued or updated to the value A. However, if this if statement were false, we would update max with the value of B. So we can see that right now A is 35 and B is 55, and right now A greater than B is false. So we should see max updated to the value of B, which is 55. So let's go ahead and run this. So again, we'll come back over to our Kotlin project, find our current class file, and then go ahead and run our class file. And we can see here that max is equal to 55. And so let's make a quick change. So we'll clear our console and close it. And again, let's say 75 for A. Now we could say this if statement A greater than B is true. So we should see now max is valued at 75. Let's take a look. So we'll come back over here to our class file, click on it, right click on it, run it, and we can see here max is now valued at 75. The typical example that you see up here for using if as an expression is a shorthand, but there's also a way to use a more long-handed block where we can execute additional code. So if we look down here, the if-else branches with bodies, we can see here the underscore A and the underscore A, and the else and the underscore B and the underscore B, they are still here. But notice now we have curly braces and we have additional lines of code to execute in the block. So same basic ideas we see up here with the using if as an expression. The difference is here now we have a more expanded if block. So if we take a look here, we can see that A is currently 35, B is 55. So this expression is evaluated. A is A greater than B is going to be false, so that means the else block will execute and then set max to whatever the value of B is, which we know is 55. We'll just scroll up just slightly, and can we see it? Close this. And let's execute. And we'll see that yes, indeed, as we were thinking or as we expect, we see here that B or max is valued to B, which is 55. Let's make a change. So let's clear and close. Let's say 85 this time. And now we will expect that A greater than b is true, so we should have max to be the value of a. And indeed, that is the case. So this is quite useful. Please repeat what we just did for your exercise, changing our values of a and b, and get an understanding of how we can use an if statement as an expression in Kotlin. Let's take a look at another familiar if conditional, and this is the if-else statement for Kotlin, exactly identical to Java, C, C++, C#, and many others. In this case, we have an expression that the if has an expression and the if has a block. If the expression is true, the if's block executes. If it's false, it goes to the next else if. So we can see these else ifs here followed in a chain followed by an else. It evaluates the expression for the next else if. If true, that else if's code block executes, and the if block is exited. So none of the others will execute. However, if any of these are false, if the else ifs are false, it will then come down to the else and execute that. Else is optional, and else ifs are optional. So exactly identical again to other programming languages. This is a great way to do some evaluation and then check for certain conditions. As you can see with these expressions, we are looking for a range with the numbers inclusive. So let's run this and see what it gives us. Again, we'll right-click on the Kotlin class file and we'll choose Run. And in this case, we had age equal to 17, and where we can see here, it's true here. So this was this expression was true, and it returned here. Now, it's important to also know that in the else if, it's going to look for or execute the first else if that is true. So there could be others that are true, so be very careful when you are designing your else if blocks. That could be a bug that is sometimes very difficult to find. So thank you for watching these videos on the different ways of structuring our if conditionals in Kotlin, and stay tuned for our videos on loops in Kotlin. Welcome to this video on the Kotlin when statement. For those of you that are familiar with the select case statements in Java and C++, the Kotlin when statement is similar if not identical. And no matter whether it's a when statement or a select case, they are similar in functionality to the else if types of blocks. So if we take a look here, we can see that day of the week is valued at 4, and then what's going to happen is the when block is going to be evaluated for that value. In this case, the value is here, so we see here that it's pointing to some kind of execution or some kind of code block, and this would be printed out, so Thursday would be output. We can also see with a more of a block body, so we can have, instead of just one line, we can actually have a block body here. So day of the week is 1, and 2 or more lines of code can execute, provided that the curly braces are there. And again, there's also that else statement. If when the when block is evaluated, if it does not find that value, it will execute the else statement. The else statement is optional. So again, we can see here that we're using it as an expression as well. So we have day of the week is 4. The when block is evaluated, finds the value Thursday, returns Thursday. So we'll see here today is Thursday for the output. There can also be branching using commas as well. So we can come in here and find, oh, okay, if we can take a look at several different values. So these two values are sharing the same code block. Also, we can look for a range. So we can see here checking whether a given variable is within a range. So we're saying day of the month is 5, and then looking for this range 1 to 7 inclusive, not in 5 to 15, and then we can put none of the above. So we're looking here first week of the month or not the first week of the month. And then
thanks for watching. Feel free to add your questions as comments down below.
And we can also check for a certain data type using the is operator. So you can give it a value and then test if it is a integer, string, not a double. And then finally we can use our when statement as a replacement for the else if chain. So you could see here we have an initial expression and and also a code block. If this is false, then it goes to the next one, the next line. If that line is false, it goes to the next one, and if that one is false, it'll execute the else. Otherwise, it will evaluate the lines in the when block one at a time until it finds a true statement and then executes that one. So let's go ahead and run. So we'll go up here back to our project, select our when expression Kotlin class file, right click and click run. So if we go back up here, we can see that since we value day of the week at 4 was found, and Thursday was output. Right here we're outputting. Then the next one, you can see here, we have a multi-line code block. We said day of the week is 1, and then it put Monday, first day of the week. Now we're actually going to use use our when block as an expression to value day of the week string. We go through again. We initialize day of the week. We evaluate the when block. The value is found, and Thursday is passed back to day of the week in string. And we can see here today is Thursday. Thursday comes from here 4. And now we can see we can combine multiple branches using commas. So we're combining these values. So the when is going to search for the value of 6, and the value of 6 and 7 using the comma can share the same code block. So in this, if it's 6 or 7, we will return the weekend. So you can see here weekend, and here we are looking for a certain range using the when block. So day of the month is 5. We're looking for in the range 1 to 7 inclusive. We'll output this code block. Not in the range using that bang in, and 15 to 21. Then we're not in the 3rd week of the month, and then we have the else, none of the above. We can use the is statement to determine. In this case, we're going to look to see if a value is a certain data type. So we can tell if X in this case is an integer, a string, not a double. You can see here it's an any. And then we're using as a replacement for the else if chain. So in this case, we're valuing number as 20, and then the when block is evaluated to look for when number is equal to 20, to look for that for a true line. Here, less than 0, obviously that's false. 20 divided by 2 has no it has no remainder, 0 remainder, so that is true. So this is the first line that's true. And we can see here number is greater than 100, that's false. And so since we found the first true line, the when block was exited, and we can see what was printed here. So thank you for watching this brief video on the Kotlin when block. Welcome to this video on Kotlin while loops. We have our project here, a project we've been using in the last few examples. It's called 5A conditionals. We have a package called loops, and one of the class files in the package is called whileloops.kt. You can see the package here, and you can see it referenced in this class file. We have our main method here in our class file, and we can see our while loop. While loops are identical to the way they operate in C, C++, Java, and other programming languages. We have a while with an expression, and then we have a code block. The code block is typically defined by the curly braces. The code block will execute as long as the expression is true, and the code block will perform some kind of an operation on the expression. Ultimately, when the expression becomes false, the application exits the code block and moves on. So we can see here that we initialized an integer x, and our expression here for the while loop is while execute this code block while x is less than or equal to 5. And then we simply print the value of x. Then we increment x by 1 every time. So first time x is 1, the next time it's 2, the next time it's 3, and then as you can see clearly here, ultimately this expression will become false, and the application will exit the while loop because at some point after about 5 iterations, x will become greater than 5. So let's go ahead and execute. What I'll do is I'll come over back to our project, right click here on the class file and run, and we can see here exactly what we discussed. X was 1, then it was incremented to 2, then incremented to 3 in output, incremented to 4 in output, incremented to 5. The expression becomes false and the application exits the while loop. One thing about a while loop though, if the expression in the while is never true, the code block will never execute. So that's one thing to keep in mind. If you do need it to execute at some point, there is a different looping structure that we can use, which we will talk about shortly. Thank you for watching this video on Kotlin while loops, and in the next video we are going to continue to discuss looping. Welcome to this video on Kotlin do-while loops. If you're familiar with do-while loops in Java, C, C++, .NET, they are identical. Also, do-while loops are very similar to while loops. The big difference is for the do-while loop, the while expression is evaluated at the end of the loop. So we can take a look at the structure here. First we have the do keyword, then we have the code block, and then we have the while and the expression. So the code block will execute at least once, and then the expression will be evaluated whether it's true or false. Just like while loops, do-while loops will continue to execute the code in the code block as long as the while expression is true. The code in the code block operates in some way on the expression, and when it becomes false, the application exits the do-while loop and moves on. This is a really interesting example. So you could see here we're initializing x as 1, and then we are going to loop here and increment by 1 until x is greater than 5. And then we go to the next do-while loop. We have x equal to 6. Notice the expressions in the while are the same. We initialize x to 6, and even though the expression is false, this do-while loop, the code blocks, executes just once and outputs the new value of x, which is 6. So this is a great example. So let's run this here and take a look. So I'll go over here to our Kotlin class file, right click, and select run. And we'll see the output here. We're not using print line, so it doesn't create a new line. So we can see here the loop, the first loop went executed 1, 2, 3, 4, 5 times, and then the next loop executed just one time because this expression, the while expression, became false from the incrementing up here in the first do while loop. So thank you for watching this video on do while loops. Stay tuned for more videos. Hello and welcome to this video on the Kotlin for loop. Again, we have our Kotlin project over here, 5a conditionals with our loops package, and we can see here our forloop.kt Kotlin class file. We see our package is loops, and we have our main method. In Kotlin, the for loop is very, very similar to the for each loop. So there is typically some kind of a range or possibly an array, and the for loop will iterate through the range or the elements of the array. So if we take a look here, we can see that we initialize the value here as an integer, and we can see the range it's initialized to. So we're declaring value as an integer. We initialize it to the low end of the range, and then we are printing each value or each member of this range. So you can see here the output. Then we are just outputting a header here for formatting purposes. Now we're declaring a prime numbers array of integers. So you can see here our array of integers. And now we are coming in here, and number is going to be our integer. And what it's going to do is for all of the members of the prime numbers array, it is going to iterate through, and each member will be the number. So the number pointer or iterator is going to look at each member and temporarily assign it to number, and then it is going to print out number on each iteration. So we'll actually see the elements of the array get printed out. Similar again, we can see that our array again is here, our integer array of prime numbers. Although this time in our for loop, we have index, we're declaring index in prime numbers, and we're using the indices. So we are going to this time iterate through the indices, and we have some control of the indices here. And now we're formatting again, and in this case we have we retrieve an array index and element in each iteration using a with index. So here you can see we are validating the index, and we're also validating number, so that's going to assign the members of the array temporarily to number. And with the particular index, we are going to output the index and the index of the array. And don't forget, arrays are zero indexed. So the first number here, which is 2, is going to be the 0th member, and the second element is going to be the first member, and the second, and so on. So we'll see here the output. But the label prime is going to have the index and the actual value of the element in the array. So if we go ahead and run this, so we'll go over here, we'll select our Kotlin class file in the project, right click and go down to run, and it'll compile, and we'll see the output, the initial output. We can see here that we had the range, and what we did is we iterated through the range. So we did almost a for each, and each element in the range was temporarily assigned to value. So we can see here we went 1 to 10, and we use print there. Then we have prime numbers right here with the colon, and we are iterating through the array prime numbers. So we initialized number, and then we iterated through prime numbers, temporarily assigning number to each element. And then we can see here the 2, the 3, first time number was 2, second time number was 3, third time number was 4, and so on. And then we moved on here to the indices. It didn't add a return line here, but we can see here that we are using this prime number and we are using the indices. So we're able to capture our index here and then output that with our value. So we can see the prime numbers and their index and value. And then finally, we can also use with index here. And we have a space, we're getting our space formatting right there. And similar output with the with index, it's just a different way to do it. We can see the with index and the number there. So in this case, we're outputting the value with by passing in the index.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
This time we're taking number and we're temporarily assigning number to the indexes of the array. So thank you for watching this video on Kotlin for loops. Again, they're very, very similar to for each loops. So if you understand for each loops, you won't have a problem at all with the Kotlin for loops. And everybody stay tuned for more videos. This is our final video on Kotlin loops. In this video, we're going to look at breaking the loop and continuing the loop. So break and continue as far as looping is sometimes a little confusing, but it's really not that hard. The break command breaks out of the loop completely and then execution continues for the rest of the application. The continue command simply it skips that iteration of the loop, and so it immediately goes back to the top of the loop and continues from where continues after the continue command. So it skips an iteration of the loop, but it does stay in the loop. As soon as the loop exits, then the application continues. So if we take a look here, we have a for loop, and again, we're going through the range. We're testing the value of, we're testing the value of value. If it's equal to 4, what we're going to do is break out of the loop, and we're going to send a little message, and that will take us completely out of the loop. So in this case, if we are looping or iterating 1 to 10, if we hit a value equal to 4, we'll break out of the loop. So it will only, this loop will only iterate 4 times if we're going through this range. Different from if we take a look down here, we are still iterating through this range. However, if the value is equal to 4, what we're going to do is continue. So what will happen is when value is equal to 4, we'll hit continue and the execution will go back to the top of the loop. It will never come down here and print out the value when it's 4. So we'll never see we'll never see 4 output. It'll completely skip that step when value is equal to 4, but it will then continue with the loop. So let's take a look at the output. And the output sometimes makes it clearer with this example. I usually provide some kind of an example like this when we're talking about break and continue for my classes. So we'll run here. It'll compile, and we'll raise this up slightly. So we can see here when we are using break, the loop begins to execute, but as soon as the value equals 4, we break out of the loop. So we hit the break command and we exit the loop, so we only go through 1, 2, 3, and 4. And then we continue the execution down to this for loop. So with this for loop again, we reset our range, and as soon as value hits 4, we'll hit continue, and what happens is the execution will return back up to continue with 5, 6, 7, 8, all the way up through 10. So we can see the output here. 1, and obviously this if expression was false, so the value is output. Same with 2. Same with 3. However, when 4, notice there's no 4 in the output because continue was reached because this expression became true in the if statement, so we went back up, and then the next time we came down, value was 5. So we can see 5 output, 6, 7, 8. Now we can, I notice I have some output here commented out. I commented out for this example because sometimes it'd be confusing because you actually see something there. The output though is the output in the if block. It won't be this print value, but if we remove the comment here and then we come back up and we run, we'll notice that we will have some output after 3 and before 5. It just says that it's skipping that iteration of the loop. Let's try it. We'll right click here and run, and it's recompiling, and we'll see here I use the /t for tab, so we can see it did not execute this print line value, but it did execute up here. It's 4, and they're skipping that iteration of the loop. So thanks for watching this video on and this video block on Kotlin if statements and loops. And again, the difference between break and continue is break breaks out of the loop completely. Continue just skips a particular iteration of a loop. Once again, thank you for watching these blocks of videos on Kotlin ifs and loops. Welcome back to this presentation of the Introduction to the Kotlin Programming Language, brought to you by Coding Bootcamps. This is Section 6, Kotlin Nullable Types. Welcome to this video on Kotlin Nullable Types. All variables are by default non-null in Kotlin. So we can see here that we are declaring a string, and the string is not null. When we try to update the value of greeting from the hello world string to nullable, we are getting a compile error here. And if we hover over, we can see the error, null cannot be a value of a non-null string. Just comment that out to remove that error. However, though, we can declare nullable variables by appending a question mark in the declaration. So we can see here, same steps as earlier. However, though, we have the var nullable greeting declared as a string, but we're adding the question mark. And then we can see here the variable is nullable. And then we can see here again, we have another nullable variable here. And when we come down to here and we update the value of nullable greeting to null, we can see here that this does work. So by default, all values are non-null in Kotlin, but we can explicitly declare non-nullable variables. Welcome back to this video on working with nullable types in Kotlin. We saw in our previous video that by default all variables are non-null and they must be explicitly declared as nullable. So we have our greeting, which is not null, obviously here, and we got a compiler error when we tried to update the value to null. But we were able to use the question mark to create nullable variables. We have a nullable variable right here. Also in Kotlin by default, we cannot make method calls on nullable variables. So again, we have greeting here. We are calling the length method, and that returns an integer. And we know that greeting is non-null, and there is no compiler error here. Same thing with the calling the toUpperCase method on greeting. Again, greeting is not null, and we are able to return that string. And here we're just outputting the results of the method call. But if we come down here, we have declared up here a nullable variable called nullGreet. And let's try to call length on that variable. If we take away the comments, we see, oh, there's an error. And we see here that the call is not allowed because it is nullable. So let's remove that error by commenting that line back out and saving. So let's run this now. So we can go to this play button, which we have not been using, but this can be a little more convenient. It's just to the left of the main method. So we'll click here and click run, and we'll let it compile. So here we see the output here, nullable greeting, and we can see here the value of greeting. And if we come down here and we want to see a null, we declared a nullable variable called nullable greeting, and we gave it a value, and then we updated that value to null. And in this case, it works. So we're able to get that to compile and get results. You can see here the results from calling length on greeting and to uppercase. We can see here the length is 12 and hello world. So stay tuned for more videos on nullable types in Kotlin. Welcome to this video where we are going to discuss Kotlin safety with respect to null values. One thing before we get started, please look in your learning materials in the Kotlin class files for exercises that are in comments or that are commented out. Follow the instructions, remove the comments, and try out the lines and look at the results. One way to manage null values or to avoid null values is to use something like the null check. Kotlin gives us lots of ways to manage null values because in life and in business there's a lot of variability, a lot of unpredictability, and we just need to manage situations. We can't always be sure of a non-null value. So here we're just using a simple if. So we're testing here if nullable name, we see here we're declaring nullable name as nullable. So we're going to test, indeed, is it null or not null? So we put in this if statement here. If nullable name is not null, if that's true, we output and we work with nullable name. Else, if it turns out that nullable name is null, we stay away from nullable name and just output hello guests. Kotlin also gives us a safety operator. We can see the safety operator right here. And what this particular safety operator does, the question mark dot, is when we use it, Kotlin will return the results if the value is not null. It's pretty obvious. If the value is null, it'll return the null. So without a null pointer exception. So it'll avoid the null pointer exception. So that is going to be useful in the case of lists. So we can take a look here at some output. So let's just go ahead here, back up to our project, right click and run, and we can see some results. When nullable name is John null, we can see hello and the conversion to uppercase, the length, and we can see here that the John null was not null, and we can see the output here. But let's change the results or change the input and make nullable name null. Clear here, and let's run it one more time. And we can see we have null guests. And here, our output here, we did get a null returned, but no null pointer exception was returned. Let's take a look at when we add let after the question mark dot. So it's question mark dot let. And the question mark dot let safety operation is used only if we can guarantee the variable is not null. If the variable is null, then none of the operations, none of the methods will return any results. So if we take a look here, we are nulling out nullable name and we're using question mark dot let. First time we run this, we'll see that nothing will be returned from any of these methods. And we can see here the last results that we got was from up here, where nullable name John null went to uppercase. Now let's do this. Let's go down and let's add. First we'll clear the console. We will update the value of nullable name by removing these comments. Then we should see some output from these two methods. Let's try it.
Thanks for watching. Please like and share this video.
And then we can see here, we've updated the string here to John null again, and we can see John null again, uppercase, and we can see the length. So the $.let safety operator only performs or returns results when the value is not null. Let's discuss another safety operator in Kotlin called the Elvis operator. The Elvis operator looks like a question mark and a colon. And what the Elvis operator allows us to do is evaluate two expressions on either side of the operator. So if we take a look here, we can see nullable name and then a string, in this case guessed. If nullable name is not null, then this result can be returned. However, if it happens that the expression here on the left is null, then with the Elvis operator, the not null expression on the right side can be returned. So it's almost like an if-then, except looking for null, not null. For an example, let's go up here. We see nullable name variable initialized, or the value is updated to null. And then we're going to go down here and we are going to return nullable name, or the expression on the right, back to string. Similarly, with this next example here, we have nullable name dot length, or we can return -1 if nullable name is null. So we see here the dot length, we're calling length on nullable name, and if that is nullable, we will get back the we will get back the -1, and then we can see the output here. So we'll go up here, back to our project, right click on our null safety class file, go down to run, and let's take a look at the output. We're starting right here. Name is guessed, because we see here name is guessed. So we could see here that with the Elvis operator, nullable name was set to null, so we got guessed back. And in the same way here, since nullable name was null and we called the length operator, the Elvis operator returned the -1, and we see here the actual value of nullable is null. There's one more safety operator that we're going to discuss. We can see it here is the double bang that is added as a suffix, just like the others, after the value. So what's happening here is the value or the property or the variable, when we use the double bang, we are guaranteeing the compiler that the property is not null. However, if when using the double bang we do pass a null property, we will get a null pointer exception. So we can see right here, we have to be careful that when using that the value is never null. So let's take a look here. So we have nullable name, and we are passing in a real string value. So right now the property is not null. So we'll go up here to our Kotlin class file, right click and run, and we'll see the results. We'll see here that nullable name, Uncle John null, because we updated the value of nullable name to Uncle John null. We called the toUpperCase method, and we see here toUpperCase. So that worked fine. Now let's comment out our update, and make a new update where nullable name is null, clear the console, and now let's run one more time. And what we're going to expect to see that since we're guaranteeing nullable name to be not null, we'll expect to see a null pointer exception when we get to this line 94, where we're using the double bang. So let's again go back up to our Kotlin class file, right click, run the Kotlin class file, and we see we do indeed have our null pointer exception. So thanks for watching this video about the Kotlin safety operators, and stay tuned for more Kotlin videos. In this video, we're going to take a look at nullability and collections. So our first example here, collection of nullable types. Notice that the question mark allowing nullability is right after the int or the type. So what this is saying is that the list itself will allow a null value. It is declared as a val, so we know that that is not null. And if we come down here and try to update the value of list of nullable types, if we remove those comments there, we'll see we'll get an error that talks about null values are not allowed. But because we are using our question mark here with the types, we allow a null value. Come down here to a nullable collection. Notice that the question mark is outside of the greater than and less than signs. So now this is allowing a nullable collection. We can see here there are no null values, but look here, we're taking the collection, we're updating the value to null, and that works. Now we're coming down here to a collection where we have a nullable collection of nullable types. So we're combining the first two. We can see here we have nullable types. We have our question mark inside of the greater than and less than signs, and then we have our question mark outside. So the collection itself is null, and then the types are null. So we can see we're allowing a null type. And here we are able to update the value of the collection as a whole to null, and that still works. Once again, this has been our presentation of our videos on nullability and Kotlin. Thank you for watching it, and stay tuned for more videos. Welcome back to this course, Introduction to the Kotlin Programming Language. This is a presentation of Coding Bootcamps. This is Session 7. Here we will discuss Kotlin functions, methods, and arguments. There will be 5 videos in this presentation. In this video, we are going to discuss calling Kotlin functions. So if we take a look here, we have a new project called 7 Functions, and you can see the layout is typical of what we've been using. We have a class file here called functions KT, and this is if we are going to compare with Java and C++, this would be the equivalent of the Kotlin class. You can see here the main method or the main function. In Kotlin we interchangeably use function and method. So here is the main function, and you can see here it's calling avg, which is a function in the class. It's calling average single expression, which is also a function in the class, and then it's saying print average. Now what's different, or what differentiates these, is this first function up here, avg, has the return type specifically declared here. So we have our 2 parameters, which a is going to be a double, b is also going to be a double, and this function is going to return a double. Then we have a single expression function where the return type is implicit. So we can see here we say it's equal to we're passing in doubles, and it'll be an implicit returning of a double. And then finally here we can see this is a unit. So this is similar to void in Java, or exactly identical to void in Java, where there won't be any data returned, but the function will still do something. So here where this function is receiving two doubles, A and B, and it's printing out the it's doing some calculations here and returning that calculation. Down here in the main method is where we're actually passing some arguments. So you could see here for A, we can see A here throughout the class. A is 4.6, B is 9.0, and so we can see here how these different functions will operate on these parameters that are passed in. You can see how they're called. So specifically we're saying A is 4.6, and you can see here it's the Kotlin functions are looking for A. Same with B. They are looking for B, and obviously the data type needs to be consistent. And so since this is the main function, we have this run arrow right here. We can always click on this. So let's take a look at our output. So we'll click on our run the class file, and you can see here that we got the average of 4.6 and 9. You see output here. Again, the average of the single expression function, even though there's no declared return type, it still is, it's the identical operation as the function above it, so we're getting the same result. And then we can see here the average of, and we can see here A and B here equals, and we can see the calculation again is 6.8. So it is very, very similar to how methods are called in Java, and same with C++. So if you understand those, picking this up is won't be too bad at all. Just some syntax differences and some nuances with terminology. So thank you for watching this video, and stay tuned for our next videos. Welcome back to this video series on Kotlin functions. Right now we're going to look at default arguments with Kotlin functions. So Kotlin gives us this ability to create some default arguments, so we can actually call the functions in different ways, and we don't always have to pass every single parameter. So if we take a look again, we have our class file called default arguments in this case. And again, what we see here is something very, very similar to a Java class or a C++ class or even a .NET class. You can see here we have our Kotlin project, 7 functions, and we have our functions package. We can see the package referred to up here. One of our functions here, we can see the default. We can see here the default value. So if name is not specifically called, it will Kotlin will take the default value as a parameter and add it to the block for the function. And similar down here with this mathematical type of a function here, we can see these 3 parameters. But the default one we can see here isn't being called, so we are here, it's being valued, so it will then be used in the actual calculation. If we see how these are called, we can see here display greeting is one time called with a specific, specifically called with the parameter name given a value. And then the second time it's called without name given a value, so therefore it will take the default value that's provided in the function. And then again, the same thing here. We're not specifically valuing or calling or passing in D for arithmetic series sum. So, but Kotlin is allowing us to have that default parameter preceding the non-default parameter. So again, Here is our main function, and our main function is calling our the functions in our class. So let's click on this execute arrow here and run this class file and take a look at the output. So again, we can see here the display greeting. First time, John is specifically valued as name, and we can see where name, we can see the order here. So it's saying hello, John. And the message is welcome to the Kali Coder blog. Then the next time this is called, its message is the only parameter being passed in, so therefore the default value is going to be used. So we can see here then Kotlin outputs.
Thanks for watching. Feel free to add your questions as comments down below.
Hello guest, so it's getting that guest default parameter. Welcome to the Kali Coder blog. And then we can see here we're returning the integer here, but we have the mathematical series sum and how the default parameter was used there. So please take a look at this for your assignment, and please take a closer look at the previous video, and go ahead in here and substitute in different default names or default parameters or default values and see what different output that you can get. And thank you for watching this video, and another one will be presented shortly. Welcome to this video on Kotlin named arguments for functions. If you're familiar with Java or C++, the position or the order that the parameters are passed to a method matters. So Java will interpret the parameters as they're passed in exactly in the order. With Kotlin, we can actually name our parameters and pass them in, and we can change the order. So if we could take a look here, we can see we're calling that arithmetic series sum function from a previous class, and we're calling it in this one, and that's fine because we're all under the same Kotlin package. So we can see here we are saying that n is equal to 10. So we are telling it here n is equal to 10. So this is a function call with our named arguments here. And then the second time we call it, we are calling the same function, but we're saying a is equal to 3, n is equal to 10, and d is equal to 2. And then we're just putting some output here. And you can also reorder the arguments if you're specifying names. So the position really doesn't matter of the parameters here. So you can see here n is equal to 10. We're calling it in a different order than we saw up here. D is equal to 2 is a different order than we saw up here. And A is equal to 3 is a different order. So, and we can see the output there. And then finally here, you can also use a mix of arguments and position-based arguments. As long as now this is important, the position-based arguments are placed before the named argument. So we can see here this position-based is before our named arguments here. And it is, again, it's just a slightly different way of calling a method or a function. Using names gives you some advantages, but really it is not that much more or that much different from a method call or a function call in a Java, C++, .NET. So let's take a look at the output. And as you can see here, our class only has our main function, and that's fine because it is able to see the this actual function in a different class. So let's click on our execute button. And we can see here the output from, so if we went back and we were able to, we won't do this here, but for your homework assignment, when you run this one, go back and take a look at the the function arithmetic series sum in the default arguments file. You can see it right here, and just take a look at these different calculations and these different results based on the parameters that were passed in. So that's it for this video for named arguments, and the remainder of the videos will be coming up shortly. Welcome to this video on var args, or variable arguments in Kotlin. So Kotlin allows us to be able to use this var arg keyword, and what this does, it allows us to pass a number of parameters, not just one set number, but a different listing or a different number of listings of arguments with the same type. So we can see here in this function here, sum of numbers, and this is actually overloaded. You can see here we have two sum of numbers. We can see here that this is returning a double, and we have the var arg, so we could pass a different amount of actual parameters. If we come down here, we can see we're passing two doubles, and then if we go down a little further, you can see here we're passing six doubles here. And then down here you can see we're passing 1, 2, 3, 4, 5, 6, 7, 8, 9 doubles here. So we can also see here that both of these are returning a double, and we're using the initial sum here. So this is a var arg with actually another parameter. So if we're just passing numbers, that it will be this function. If we are passing numbers and we are adding another initial sum, then we are going to call the other function. We can see here with initial sum. So if we go down here, we can see that sum of numbers is called with numbers, and in this case it's 2, but then we see initial sum called. So that would then call our overloaded function, but it would call this one because of the way that the parameters are being called. And then we can finally also use arrays. So here we're declaring an array, and we're valuing that array, and we're calling sum of numbers using the star a here. So it will also use these doubles here as the variable or the listing of our variable arguments here. So in this case, it would just treat it as 3 doubles being passed to, in this case, it would be this sum of numbers up here because there is no initial sum. So let's take a look at some output. So again, here we have our main function. And so we can click this run arrow next to the main function, run the class file. And if we take a look here, we can see that we called sum of numbers. So we called the very top one, and it ran this calculation, and we're getting 3.5. The next time we called it, where we passed in this time these 6 doubles, and it's all still numbers. So notice we're still passing but it's a var arg called numbers. So we're passing in numbers, but this time it's these 6, and we're getting a value of 23. And then we're passing in numbers again, only this time we're passing in these 9 doubles, and we're getting 60. Then we come down here, it's sum of numbers. However, we're passing these 2 doubles called numbers and then initial sum. So because this function is being called this way, Kotlin in this class is able to say, okay, this is the sum of numbers that's being called, and the calculation is being done that way using that function. And then finally, we can use an array as our listing here, as our var args. So we are doing sum of numbers and you can see our output is 9.5. So please take a look at this, and as you go in for your assignment, please go in and do some changing up, adding or removing some of the amount or the list of the numbers. I have to be careful with the word list because that actually means something in Kotlin, but the number of the parameters being passed in. We can even change up the array, and also try with another way, or another time calling with initial sum, and see what kind of results you get from that. So thanks for watching this video on Kotlin var args, or variable args, and stay tuned for the next video. Hello, and welcome to this video on Kotlin function scope. So we can take a look here, and Kotlin actually gives us the ability to create local functions within functions, or nested functions. So we can take a look here. We have our top level function here, and then it has the top level function actually has two if statements, and then down below we have a nested function that actually has access to the local variables that are passed in to the top level function. So we can see here weight in kg, height in centimeters. This nested function down here, so it's a function within a function, actually has access and can do the calculation. So we can see here this return. We can this function here, calculate BMI, actually completes a return, and then we can see here that calculate BMI is returned by the top level function. So we can actually see that scope here. Calculation is done here, the name of, and then the actually a function call and a return are actually made by the top level function. So our nested local function has access again to the local variables that are passed in from the top level. Our nested function will do the calculations, and then there's actually a function call where we can see a double is being returned by the top level function, and we can see here that the nested function also returns a double. So in this function call, the double is returned, and the double is returned here back when the main function is actually executing or calling find body mass index. And you can see here these parameters are being passed in. So it's almost like a hierarchy how these functions are arranged. So take a look at this. We can add to this slightly. We're just doing some logic here. Obviously, we have to have weight has to be greater than 0. Height has to be greater than 0. But just take a look at the structure of the nested local functions, and just understand how the top level function and the nested functions are working together, and what happens when the top level function is actually called. Let's take a look at the output. Here is again our main function passing in the 68.5 and the 70.0, both doubles. So you can see here they're being declared as doubles. This find body mass index will return a double. We do some business logic validation here. Then we are actually calling calculate BMI, which is right here. And again, calculate BMI has access to height in centimeters and weight in kg, and the calculate BMI does the business logic, completes the business logic, or does the calculation, and then this function is a double, and so this a double will be returned here back to the ultimate calling function, which is in the main method, or the main function. So let's go ahead and run. So we'll click on this arrow. And we can see here that from find body mass index with the weight and the height being passed in, we can see here how the calculation was made and returned back to the console. So thank you for watching this video series, and stay tuned for other videos. Once again, thank you for watching this video block on Kotlin functions and parameters and variable parameters. Again, this was a presentation of coding boot camps. Please stay tuned for more videos.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Welcome back to this course, Introduction to the Kotlin Programming Language, presented by Coding Boot Camps. This is our final session, session 8. We're going to look at Kotlin infix function notation. Kotlin provides us this way of creating, you can see here a data class and in what we call an infix function. And you can see how the infix function is built here. What we have here again is a typical Kotlin project. You can see here we have our source file, create our package here, t9_functions, and then we can see it referenced here. And our Kotlin class file is right within the package. So we can take a look at our main function here. So we're declaring two values, two variables, C1 and C2, and they are based on the complex number function that's up here. So, and notice here there are two different ways of calling the adding. So this infix function here is just simply called add. And notice here there is a usual or a typical call we can see here where we just say we're calling add on C1 and we're passing in C2. So we're calling add here on C1. We can see the add method and we're passing in as a parameter C2. But there's also an infix call here where we can just simply say C1 call add and then C2 right after that. So this is considered to be, I guess you could say, more intuitive as far as making functional calls. So making it possibly a little clearer because obviously this usual or traditional notation here can be a little confusing at first. So and could use there may be some commenting required, whereas down here it's almost clear from the beginning what is going on. So if we look up here again, we can see here that we have real part, which is a double, imaginary part, which is also a double. You can see here we do some addition of the real parts and the imaginary parts. And then here we actually have then we call complex number, which is right here, complex number, where we call it with the passing in the real part and the imaginary part. And you can see here the doubles that are passed in. And notice we are returning a double here. So it's similar to what we looked at in a previous presentation. So again, we are then returning this, we're returning the results here from the infix function. So let's take a look here at the two different ways we can return the results from these two different function calls. Click here next to our main function, this run arrow, and click Run Infix Notation. And we can see here that complex number, we can see real part equals 6, and we can see imaginary part equals 12. So, and you can see here how everything was just put in here, how these two, 3 and 3 is 6, and 5 and 7 is 12. And then it's just simply presented in two different types of method calls. So again, C1 and C2 were added within this complex number function, and there were these two different ways to call. So please, for your assignment, please take a look, try passing in here, updating our parameters here, maybe even add another value here, complex number, and take a look at the different results you'll get. And thanks for watching this video on infix notation in Kotlin. Thank you again for watching this video on Kotlin infix notation. And thank you for watching this course on the introduction to the Kotlin programming language. Again, it's been a pleasure presenting to you. And this course, Introduction to the Kotlin Programming Language, has been a presentation of Coding Bootcamps. Please stay in touch and look for more courses in the future.